Repair Foundation YouTube channel. Today we are going to look at estimation of precipitable water and amount of rainfall, how to estimate them, given with reducing ascent data. That is when you have pressure and specific humidity. How do you then estimate the precipitable water and use it to determine the amount of rainfall or the amount of precipitate that would occur at a particular area? So we have an earlier video which has been included in the description box on the explanation on how to go about this kind of problem. But here we are going to just go into the question and solve it. Learn how to what? Solve this problem. All right. So just as I said, if you haven't subscribed to the channel, make sure to subscribe, like, share, and comment at the end of the session. If you have any challenge, make sure you comment and your issue will be addressed. So let's see. The observation in the table were taken from a radius-sun ascent. If 70% of the precipitable water is produced from the air up to the 660 millibar level to form precipitation at the ground level, what would be the depth of rainfall? So this is the question. And so we are supposed to solve it. Now we know that the precipitable water equation is given by 0.1 over G multiplying the sum of the average of the specific humidity and so we are looking at the sum of the product between the average specific humidity and the change in what pressure. So this is the formula. So we are going to draw a table where we will need a change in pressure and we will need what the average. Now the change in pressure is given by the column that you find yourself. So the column that you find yourself minus the column that is next or the next column. So if I want the change in pressure, let's say this is my change. If I want to change in pressure at this point, it is the column here minus the next column. If I want to change the pressure, it's the column here minus the next column. But the average specific humidity is given by the column that you find yourself plus the column that is left divided by what? By 2. So if I want what the average is simply this plus this divided by 2. So it's going to be 14.80 plus 14.20, and this weighting divided by 2. So if I come to this column, it is this plus this divided by 2. They get it. So I'm going to draw a table, then we go into details, right? All right, so this is a table. So this is going to be change in pressure. This is going to be the average specific humidity, and this is going to be the product of the change in pressure and the average humidity, right? So just as I indicated, if I want, it's going to be 110 minus 920. So the column that you find yourself minus the next column, you get it? And so let's put them down. Let's put them down. So 110 minus 920 will give us what? A minute. 110 minus 920 will give us 90. When we come here, it's 920 minus 890. So your column minus the next, right? So 920 minus 890 is 30. The next is 890 minus 810. 890 minus 810 is 80. Then 810 minus 720 is 90. Then 720 minus 660 is 60. Now we will end here. Why? Because the question said up to the 660 millibar. So when we got here, it was what? 720 minus 660. And that gave us what? That gave us 60. Now when we come into the 660 minus 660, it means that we're going to add 660. Well, meanwhile, they say we should end at what? So we're going to add 620. Meanwhile, they say we should end at what? 660. So this side cannot be priced. So all this side will be struck out. All this side means that the data here cannot be reliable per the question that we have. You get it? So mostly where they ask you to end under where you are ending, there is nothing below it column going down. So because they said I should end here 660, said I should end at 660. Under the 660 column, there's going to be nothing there. There's going to be nothing there. And the column below it also will be nothing, right? When I come to the average specific humidity, so the column has to find it. So this is what 14.80 plus what 14.20 all over 2. You see it? So the column has to find itself, and the column that you find yourself and the column next is what the data inside is what you use. So what is this? It's what we use. So this one we are going to get what 14.5. Yeah, 14.20 plus 12.30 divided by 2. We will get 13.25. Then here 12.30 plus what 11.50. That is what 11.9. And here we have 11.50 plus 10.20. That is 10.85. And here we have 10.20 plus 8.60. And that is what 9.4. So we find the product. So 90 times 14.5. That is 1305. 30 times 13.25. That is 397.5. Then 80 times 11.9. That is 952. 90 times 10.85, that is 976.5, and 60 times 9.4, that is 564. Then I find the sum of the product, So that is 1305 plus what? 397.5 plus what? 952 plus what? 976.5 plus what? 564. And if I find the sum, I'm going to get I'm going to get 4195. So with the sum gotten, I can now find my precipitable water. So the equation for finding the precipitable water, just as I indicated, just as I indicated, is given by this. So in that case, so 0.1 times G, which is 9.81 times the sum, which is 4195. And this is going to give us what? It's going to give us 42.762 millimeters. Now the question said we should find what? The the precipitation at the ground. If 70% of it, 70% of the precipitable water precipitated. So that would be the amount. So the amount of rainfall or precipitate is given by 70% of precipitable water. Let's see. So in simple terms, it's going to be 70 over 100 times 42.762. And that is going to give us. So let's see what is going to give us. My calculator, a minute. So 70, and this is going to give us 29.933 millimeters. 0.933 millimeters. Thank you very much for watching. Make sure to like, subscribe, and share. This is where we end. You can check the next video by clicking on the card shown. Subscribe. And thank you very much for watching. Educare Foundation, because we care. Bye.